Let's look at drawing graphs of hyperbolic functions. Question 1. Sketch the graph of g of x equals to 4 over x minus 2 plus 2. The first step is to determine the asymptote. The horizontal asymptote is the line y is equal to q, and the vertical asymptote is the line x is equal to negative p. Your asymptotes in this case are y is equal to 2 and x is equal to 2. The second step is to determine which quadrant is our graph. The a value is 4, which is positive. So we know that the parent of our graph before shifting was the first and the third quadrant. To find where our graph lies, we must sketch the asymptotes of our graph. The y-asymptote is represented by a dotted line. Y is equal to 2. Your x-asymptote is represented by a dotted line. X is equal to 2. Our graph will lie above the line y equals 2, and to the right of y is equal to 2 in quadrant 1, and below the line y is equal to 2, and to the left of the line x is equal to 2. Now, let's find the x-intercept and the y-intercept. Remember, in order to find the x-intercept, you make y equal to 0. If y is equal to 0, then 4 over x minus 2 plus 2 over 1. My lowest common denominator in this case is x minus 2, so I multiply everything by x minus 2. If I multiply 0 by x minus 2, I get 0. 4 over x minus 2 multiplied by x minus 2 is a 4, and 2 multiplied by x minus 2 is equal to 2x minus 4. So, we have 0 is equal to 4 plus 2x minus 4, but 4 and minus 4 cancel, and you have 0 equals 2x. You can divide both sides by 2. You get x is equal to 0. This is the value of the x-intercept. Next, we must determine the y-intercept by making x equal to 0. So y equals 4 over 0 minus 2 plus 2. This means we have y equal to 4 divided by negative 2, which is negative 2 plus 2, which is 0. This is the y-intercept. So when I draw my graph, the x-intercept and y-intercept is at the same point, 0, 0. The part of the graph in quadrant 1 does not pass through point 0, 0. But the part of the graph below y is equal to 2, and to the left of x is equal to 2 does. We draw this part of the graph in first. The two parts of any hyperbola are symmetrical. Using symmetry, we can see the second part of the hyperbola in quadrant 1 must pass through the point 4, 4. Let's draw it in. Remember, both parts of the graph must get closer and closer to your asymptotes without ever crossing them.